Hey everyone, Eric here from Iowa Robot Fighting. So from last week, there was a significant change. The original plan was to have, 6 months to do a major revamp of Cowboy Beep Boop. And that's still the plan to some degree. But between when last video came out and now, we were able to get into the Wisconsin Robotic Combat Competition that's happening on the 26th of September, or a lot of people call it just WRC. So we have a very limited amount of time to be able to make changes. Now, I was able to get in with Cowboy Beep Boop, but Evan is not able to get in with Horns of Jericho because there just isn't enough slots available and he doesn't have the time or funding to make changes at this point and to actually go up. So my father, Dave, and I will be going up, and he'll be being a wrench spinner with me and helping run some camera equipment and making sure that I have a place to stay and things like that. So I appreciate it, Dad. Thank you very much. But that means I need to make major changes really fast. From previous videos that you can see, I had issues with my weapon bending. That was because it was made of mild steel, and if it was hit by a vertical spinner, it was liable to bend and make it inoperable. And as you can see here, there's actually a bend right in this weapon bar. And that's actually from me doing testing. This weapon bar wasn't bent there naturally. And I'll show you guys some stuff on this here in this video. But weapon bar, first change. Second change is outer armor. So as I talked about in a previous video, this outer armor was a major liability right on this edge. The plan is to wrap the armor. If it needs to stay aluminum, it'll stay aluminum for weight. But if I can help it, I'm going to change my frontal armor to a piece of plate steel. And that should increase my durability for my plate. I will likely also replace my side armor and partial rear guard armor with UHMW panels. So I'm looking at being able to bend those, and that might be coming up in the next video. We'll see. It depends on where we get. So first things first, if you haven't seen the previous video, or if you have, I'm going to give a shameless plug again. So we have brand new t-shirts in our merch store, which is listed in the description below. And go ahead and check out some of the shirts if you're a robot builder or just a fan of our designs or just want to support our channel. We appreciate you picking up one of those t-shirts or a coffee mug or a bag. We really appreciate the support that all of our viewers and subscribers give. On to what the process is looking like from here. So I obviously have a dilemma when it comes to using mild steel. It bends way too easily. However, we have another set of skills that we can apply to this, and that is forging. Now, as you can see, we actually have an actual propane forge and an anvil and everything necessary to be able to go through the process of forging metal, heat treating it, doing everything we need to do. The first step in this test process was to make this piece of mild steel. So I went ahead and cut down a piece of mild steel, and we decided we would attempt to heat treat it. The process of heat treating is pretty much straightforward. You throw a piece of metal into the forge, heat it up to glowing, and then depending on the type of steel that you're dealing with, in this case it was the mild steel, which is 1018, which is really low carbon steel, you then take it and dunk it in water for this type. And when we did that, we then ran a test on it. It then bent immediately, as you can see. So that being the case, we determined that there was no way to properly heat treat the low carbon steel that is mild steel, the 1018, to any level of effectiveness when it comes to robot fighting. So we moved on. We have at our disposal a typical blade steel, which is 1095, and you can see just how big this is in comparison to the steel bar that we typically mount on our robots. That's a bit of a problem. Luckily, we have a solution, and that is the typical forging process. So we went from this, and you can kind of see the piece here that we hammered down, and turned it into this over a painstaking process of forging and hammering. So I'll walk you through that process through all the videos we shot. So first up, we had to heat the steel and continuously hammer on it. Now 1095 is a pretty tough steel. It's pretty high carbon and can be really temperamental. But as we move through the forging process, we just heated and hammered and heated and hammered until we got it down to a point in which we were able to place another piece of steel right in the area where we were going to break off the section we were planning to use. We then heated it up to glowing, put the piece of steel there, and started hammering away. Did that a few times until we could break the piece of steel off that we wanted to use. As soon as we had that, we could then continue to work the steel into a longer and longer and thinner bar until it was right about where we needed it.
Focus on that far side.
Then it was on to the heat treat. So 1095 requires heat treating in oil. The quench needs to be done with an oil. Typically cooking oil works the best. So we went ahead and heated it up. I dunked it in the oil, cooled it down. It then came out with forge scale on it. Forge scale is, as you can see, a very rough looking hammered piece of rock, it almost looks like. Then comes the grinding. It required grinding a considerable amount of the bar down, but once I was able to grind it down to a chunk that was usable and thin enough, I could then cut it to shape and then continue to grind on it a little bit more to clean it up. But after it was cut down, ground a little bit, cooled off, I was then left with a beautiful chunk of steel. Then a problem occurred to us. As I was left with another chunk of steel that was about that long, the other chunk that I had chopped off became a test part. So I wanted to make sure I could drill through it. That became a problem. I applied so much force in an attempt to drill through the bar that I actually split the bar in two. It just snapped because it was so much force. So I then needed to come up with a solution. Now, I'm not going to implement that solution in this video. That'll be next time. I'll be doing a couple more tests, one of which I need to do what's called drifting a hole or tapping a hole into a piece of steel. This one is so hard that I just cannot drill through it. So next up, I'm going to go ahead and run a quick test to see how resistant this is to damage. Interesting. So as you could tell, The metal bar that I had that was mild steel bent relatively easily. However, because apparently I had some microfractures within my structure of my 1095, that also snapped the tip off really easily. Now, that was just one side. Once you saw that I locked it in again, it took quite a lot to get it to snap. It required getting a lot of stress on that. So there was a little bit of weakness still in the blade, but you could tell that there was strength in sections. It's a good test. I'm really happy that I got through quite a lot of this and I understand what the process looks like, but the heat treat still wasn't of the quality that was needed. So now I know where to go from here, but I also know I was never going to be able to drill through this. Because of snapping the original piece after the heat treat, this was just going to snap again. So from here, now I will be making another section of steel, probably a considerably longer piece, so I can get several blades out of it, and grinding it prior to heat treating it, drilling it prior to heat treating it, then heat treating, then doing some more buffing, polishing, grinding, and whatever else. And also probably cutting it to size prior to heat treat, or getting it as close as I can. But as you can tell, the blades are a work in progress, but they are going to be far superior to my bendable blades that I had in the past. And I might choose to go with a different steel. Since this is 1095, and it tends to be quite brittle, I am likely going to go with a 1070 or 1075, a little bit more malleable, should have a little bit more flex in it. The reason we originally thought this was 1075 when we were working with it, but we later found out that we were working with the wrong bar. So I might mess with a couple of different bars and do some tests against them and see what I've got. But that is for a later video. Also coming up in the next videos, I'll be doing the new armor work, and that will probably be coming up next for videos themselves because I need to get that worked out. I'll also likely be bringing some mild steel blades with me for going up against non-vertical spinners, because I know that those are unlikely to shatter like these. They might deflect a little bit, but highly unlikely to do any sort of shattering or anything like that. So I'll probably save my high carbon blades for instances where I need them. So with that, I think that's where I'm going to wrap it up for this video. Thank you so much for tuning in. Stay safe, and I will catch you next week.